Hello, students. I'm sorry I cannot be with you, but I'm glad we can learn this way. Today's unit will be on the scientific method, and through the steps that you'll learn and practice, you will be able to create better experiments and be able to critically think about other people's research. Science is the study of the natural world, from biology to geology, and also physics and astronomy and other areas. The basics of all science is that we are making observation and asking questions. There are many ways to describe the scientific method. This is one way that lists 7 steps that you yourself can do. The first is observe. Second, question. Third, make hypotheses. 4, make predictions. 5, test the predictions. 6, collect results. And 7, make a conclusion. You will practice the first 2 steps of the scientific method. Record this information in your notebook so that you can refer to it later, and record it with such detail that someone else can come back to the same spot and make observations and compare their observations to your observations. And then I want you to start asking questions about what you are seeing. If you are seeing insects, ask, what are these insects doing? Are they carrying food? Why are they carrying food? Where are they taking the food? Maybe you see an ant carrying a grain of grass. Or perhaps there is a caterpillar. Where is the caterpillar going? How did it get there? If you see moss or ferns, why are the ferns growing there? Are ferns growing in other areas? The more questions you ask, the more deeply you will begin thinking about the area. You will do your activity in a spot that you choose. You can do this by yourself or with a couple other people. Please remember whatever COVID cautions that you have to take. Bring your notebook and a pencil or pen. If I was there, I would give you some instruments to take the temperature and to measure light intensity. But you'll have to use your best judgment about how to describe these things. I would like you to do this activity before the next class period. And at the next class period, you will have time to talk about your observations and your questions. You can take this activity even further by posing a hypothesis about one of your questions. For instance, if you see an ant carrying food, hypothesize about what the ant is doing with that food, and then think about how you would test that hypothesis. Let's review the scientific method and discuss it in more detail. What is the first step of the scientific method? It is to make observations. So you will be making observations about something that you are curious about. What is the second step of the scientific method? It is to make questions about those observations. For example, if I see that the bird Madame Sarah is in my cornfield, that is an observation. And I could watch the birds and see what they are doing. Perhaps I will see that they seem to be eating something. So my question could be, what are those birds doing? What are they eating? I next make a hypothesis or a statement about what I think they are doing. So you use your past knowledge, and you can even do additional research in books or online to learn more about Madame Sarah and form your hypothesis, which is an answer to your question. My hypothesis could be, I think that the Madame Sarah is in the corn to find food. And I think that the Madame Sarah is eating the corn. Next, I will make predictions, such as before the Madame Sarah is in the corn, the cobs will be undisturbed, and they will be full of kernels of corn. But then the Madame Sarah will be eating the corn, and when they leave, I will see that there are kernels of corn missing from the cobs. So, when I make predictions, I then have to come up with a method to test those predictions. How would we test the prediction that Madame Sarah is eating the corn? And Elio can pause this so you can discuss. I would test the prediction by marking some ears of corn that I examine close up, and I look to see if any kernels are missing. Then I have to wait until some of the Madame Sarah are in the fields, and I look to see if they are on the corn. When they leave the corn, I go in and look at the kernels. Do I see any missing from the corn cobs? Or do I see corn on the ground? I make notes of this, keep it in my journal, and it's best to do an experiment more than once so that you can prove that it wasn't random chance that something was happening. But if you get the same results over and over and over, you can draw a better conclusion that what you think is happening indeed did happen. So, if I look at many ears of corn, I see Madame Syrah has been eating it, and there is corn missing, I can make a stronger conclusion that the Madame Syrah was eating the corn. However, my results might show that there is no corn missing. So that means Madame Syrah was doing something else. And that does not mean that I did a bad experiment or that I made bad predictions. It just means that I need to look for another solution. So my conclusion will depend on the results. And if my conclusion shows that my hypothesis is wrong, I can start over with making more observations and questions and posing a different hypothesis. Now I want you to discuss these steps with a hypothetical situation. Say that you have a garden and you're growing tomatoes, and your neighbor has a garden and is growing tomatoes. But your neighbor gets many more tomatoes than you do. So that's your observation. I want you to use the 7 steps of the scientific method to design a study to determine why your neighbor gets more tomatoes than you do. And when you are done with that, you go outside to do your assignment, or you can do it at another time before next week. So thank you for listening to this lecture.